Ladies and gentlemen, good morning and welcome back to PB Expo, day number 2. Today we're going to be here about addressing the challenges of sustainable aviation. The aviation industry, according to various estimates, contributes between 2 and 3% of global greenhouse gas emissions. Without more sustainable technology solutions, emissions are projected to grow another 300% by 2050. So far, most of the focus has been on sustainable air fuels, or SAF, as the primary way of reducing emissions. There is a myriad of other opportunities across the entire life cycle of aircraft ownership that can contribute to accelerating the industry to what the entire world is not just expecting, but demanding of our industry. Shareholders across every aspect of aviation are putting more and more pressure on boards of airlines, lessors, MROs, and financial institutions to establish and meet ever more stringent ESG goals. Let's hear from this panel talk about some creative ways the industry is exploring to affect positive change. As we introduce our panel, let's bring on stage Senior Partner of Midas Consulting Group, Paul Sejas. Let's welcome our next panelist to the stage, Vice President of Sales and Marketing for Laser Photonics, Ashley Weis. And our next panelist and moderator, CEO of Airies Aerospace, Steve Haro. Director of North American Aerospace Industries Corp., Sven Daniel Keckler.
Well, good morning, everyone. Hopefully you've had your coffee. I brought mine on stage just in case. We are here to talk about, a really important, sometimes ignored topic over the last, I'd say, decade. It's becoming more and more of a topic. And that is, what are we gonna do as an industry to improve everything from how we design and build aircraft to how we operate them, and to even life cycle solutions, including disposal, to be a more sustainable, to really deliver less greenhouse effects and impacts on our world. So we're here with a distinguished panel of experts, I think, in various areas, and I think you're going to find it quite interesting. So I'm looking forward to this conversation. It's going to be fun, lively. We're not going to be formal. We're hopefully going to just challenge each other when somebody makes a claim or a statement. I'd like us to introduce ourselves, a little bit about our companies. I'll start first. I'm the CEO of Airies Aerospace. I'm also the Chief Growth Officer to what Airies is a part of, which is a group of companies that's really designed and put together to deliver a full suite of services to the industry. 55 Group really services the commercial aviation, the defense, the security, and the space industries, including the International Space Station, and current customers are also like SpaceX. So we're trying to span all aspects of aerospace, but in today's topic, we're going to hone in specifically on commercial aviation. Sven, could you introduce yourself?
Good morning, my name is Sven Daniel Köchler. I'm the Director of North American Aerospace. Obviously, I'm the German guy, as you can hear by my accent. North American Aerospace is based in North Carolina. We aim to be able to recycle planes 100%. That's why we partnered up with Airies and Group 55. We started an initiative just a couple of weeks ago. Thanks again to Steve and his whole team partnering up with us. Yeah, let's go ahead.
Go ahead.
And I'm Paul Sejas, so I'm a senior partner with the Midas Consulting Group. My specialty is engineering. We're a company that specializes in bringing disruptive technologies to market. My background is I spent 36 years with the Boeing company, so worked mostly the defense side, did some work on the commercial side, and the later part of my career was working with MRO and unmanned systems, and on that side as a CTO for the autonomous aviation, worked a lot of the eVTOL and R&D efforts as far as the new technology. So hopefully I can bring something from the technical side and ready to answer any hard questions.
Thank you for the acronyms, Paul. We could tell he's from Boeing. At Boeing, we had an online lookup and we called them TLAs, three-letter acronyms, and we had over 44,000 acronyms used at Boeing. So I counted like 5 of them in there, so that's great. And I'm just trying to demonstrate how this conversation should go. We're going to continue to be lighthearted and really enjoy having a really difficult, challenging discussion, but really in a positive and fun way. Ashley?
Yeah, I'm Ashley Weis. Hello everyone from PBExpo today. I'm with Laser Photonics, VP of Marketing and Sales. We provide laser cutting technology, laser cleaning, laser marking and engraving, and also laser 3D metal printing. So we've been in the industry for 40 years, helping many companies out, both on the OEM side and the MRO side. But about me, I've been in the aerospace and defense industry for 20 years, Collins specifically. So I've been in both production, manufacturing, and also the aftermarket side. So sustainment is very important to me and Laser Photonics. So.
All right, so thank you guys. Let's start off by talking a little bit about what we believe from our individual perspectives. And in full disclosure, I just met Ashley, but I do know these two gentlemen on the ends here. Again, Sven mentioned that we started a joint effort to do 100% aircraft recycling, the first time ever done. And he's going to show some creative ways on not just recycling back to avoid virgin materials being pulled out of the ground and the carbon impact of that, but in terms of upcycling and using some of these products for other uses. And then Paul and I, he said 36 years at Boeing, I was 33 years, but I was on the commercial side mostly, he was on the defense side, but we've done projects together, so that's why I feel I can pick on these two a little easier than Ashley since he's brand new. So let's start off with Paul. Why don't you just start off talking about what you see are some of the major challenges around the aviation industry coming together and trying to address some of the challenges on sustainability.
Yeah, I think ESG on the aviation side is going to be difficult. And the main reason, obviously, is airplanes got to get off the ground, right? It's all about weight. And when you look at it from Boeing's perspective or the companies that make airplanes, it's really about the fuel. As it was mentioned in the introduction, 3 to 4% of the emissions come from aircraft. Excuse me. And air travel is expected to continue to grow by at least 5% a year and continuing that path here after the little glitch we just had with the pandemic. And as that happens, the real challenge is going to be alternative fuels and how do you find that energy density, right? There's a reason that fossil fuels work great, and it's how much energy they produce per pound. As you know, with aviation, it's all about weight, and finding a fuel that produces enough energy is very difficult. And if you want to keep, aviation affordable and available to the masses, you really need to replace that energy per pound. I know there's a lot of talk about alternative fuels. Biofuels is an area where there's a lot of research. Obviously, most biofuels are carbon-based, right? So what's the byproduct of that combustion process, right? So is it going to be perfectly, no carbon emissions? We don't know. So one of the fields that's coming up a lot with potential is hydrogen. We may talk more about hydrogen, but hydrogen, luckily a lot of its byproducts when it reacts is water. So that's great. People like water. It's clean, no carbon emissions, and that's why you hear a lot about hydrogen. Hydrogen carries a lot of energy per pound. The problem is it's also primarily in gaseous form, so its volume is very large. So you're going to
So
have challenges.
to add to what he's saying, hydrogen has 3 times the energy density of what is today called Jet A, or the kerosene that's used in aircraft. But it is also 4 times the volume. So I was just adding some numbers to what he was just saying, but think about that. 3 times the energy density, 4 times the volume. That's why you can't just pump this into an existing aircraft, because it's not going to go into the wings. You have to completely rethink the design of an aircraft when you're thinking hydrogen, but the payoff, if you can figure it out, is quite enormous. Sorry, Paul, go ahead.
Spot on, and actually that's why you're seeing a lot of resources going towards hydrogen now. How do you use hydrogen? People are looking at it in several ways. One is hydrogen cells. Now that's where you're converting hydrogen to electricity and using that to power electric propulsion. The other alternative is actually you actually consume it, and you have that essentially either drive a mechanical device or have it actually ignite in some way and do it that way. So there's different ways of looking at that. And then of course you hear a lot about electric propulsion, and the problem with any kind of electric propulsion in aviation, and the big challenge there is going to be, everybody wants to do batteries, right? Like the automotive industry. Well, batteries are terrible in weight per pound. They're literally a tenth, the best battery is a 10th to a 20th of the efficiency of jet fuel. So you need a 10x factor improvement minimum in battery technology to try to get that. The other alternative is doing a hybrid.
Before you jump on,
go ahead.
let me just say something about batteries. 55 Group is working with several different companies around energy sources and uses. But at Boeing, when we were looking at electrification for propulsion purposes, and we worked with GE, we worked with Pratt and Rolls, and the normal people who are working in the aviation industry for propulsion. Here's the problem: weight is the enemy of lift, and then you have drag, right? And so the drag is an issue with the hydrogen and the weight, because you have to have a bigger container to contain the hydrogen. But batteries are not only dangerous because they're lithium, and we've seen many accidents out there associated with batteries. There's a reason why airlines say don't pack any lithium batteries in your baggage in the lower cargo holds. But the other thing is if you burn fuel on a 15-hour flight, and I have a responsibility for wide-body aircraft, working with customers to design wide-body aircraft, so we're talking 15 to 20-hour flights. What's interesting about that is the airplane gets lighter and lighter and lighter over that 15 hours, but when you have a battery, it's the same weight the entire way, so your efficiency is not really improving the longer you go. So these are some of the, again, this topic for this panel is what are some of the challenges. What sounds good at first, there are a lot of technical and operational and just physics that play into why that's a challenge. All right, thanks, Paul. Sven.
Especially when it comes to batteries, there is the question what to do at the end of life with the batteries. So that's something I would like to address, and that's something we should talk about, because even if you were able to fly the aircraft with the same efficiency with a battery than you do right now with a fossil fuel, what you're going to do at the end of the life with the battery? Where is the solution for that? Do we have a solution? Do we have a solution already for that? I don't think so. No? Well, you know anything? Maybe some interns from Boeing.
You were supposed to have the answer.
Oh, okay. I thought I'm allowed to have questions too.
Yeah, no.
The only one I know who knows everything is my wife. So.
Ah, okay. Secret to a long life. Yeah. So, and then Ashley, before we jump to another topic, I'd like to get your thoughts on that too. Not just the batteries, but in general, some of the challenges.
Well, I know personally that in aviation, we deal with a lot of corrosion challenges. So corrosion, rust, contaminations, and it impacts the antennas, it impacts the exterior of the aircraft, the landing gear, and ultimately if it gets into the pressurized spaces, it also could impact some of the units that are inside of the unpressurized spaces as well. So corrosion can impact that, and then the process of getting different products back into service to remove paints or whatever it may be, those toxic chemicals, those things as well are impacting the environment in the long term. So I'd like to touch on that when it's my turn to talk about
Absolutely.
Good job.
I was joking with him earlier because I just met him, and I said, "Can I call you Rusty?" Because that's what they focus on, is eliminating the rust. There you go. We need, yes. So, and to the audience, and hopefully we're going to have a little bit of time at the end. So think about any questions you might have for the panel, because we'd love to hear from you. Wow, this is a big topic. So let's start with SAF, Sustainable Aviation Fuels. The problem there is right now we're only certifying aircraft for 50% SAF. The rest of it has to be kerosene. Airbus has made, and Boeing has made similar challenges that they're trying to achieve 100%. But Paul said it earlier, all they're doing is taking carbon that's already been taken out of the earth and reusing it. So that's one level of not adding more carbon, but you're just recycling the existing carbon. You're taking it from bio feedstock. So that could be agriculture, that could be a lot of different sources, including waste, cooking oils. All of these things become a feedstock for biofuel. There's carbon in every one of these. So the idea with SAF is it goes into an aircraft, it gets reused, redistributed, hopefully goes into the environment and gets reabsorbed by the plants, gets reabsorbed by the trees, and then goes back into the earth. And now we've got one complete cycle where we just keep taking the same carbon and using it in a circular form. That's the idea behind it, but there's a lot of challenges there as well. Number one, availability. Number two, price. Number three, reliance on the energy and oil companies to produce it. They're dragging their feet in many cases. There's not a lot of incentive there. So the challenge with SAF is, getting the volume you need in production in order for it to be cost effective. And then every airport you land at, you have to have it there. And if you're not producing that SAF locally, you have to ship it there. Now you're burning carbon moving the SAF to that remote location. So all of these things are what makes it more complicated than just, hey, let's just take our cooking oil and our lawn waste and turn it into fuel for aircraft. It's way more complicated than that. Any other thoughts on SAF?
What did SAF stand for? I just reverted to
Steve always
Finds a solution.
finds a solution.
Okay, I wanna put on that, like especially the storage of the SAF is a different one than the one you have right now for jet fuel. So if you're using a jet fuel storage for sustainable fuels, you cannot reuse it again for jet. So that's another one. So we don't have a storage for that yet, and it has to be anywhere, and it has to be a different one, and it has to be treated different one, and there has to be regulations in place for especially SAF fuels and the storages and how to handle it.
Absolutely.
So yeah, I agree, Steve. I think that's the challenge is between the logistics, and obviously logistics is always a big issue in the aviation market. And even if you use those fuels to try to drive electric energy, which is the other thing we talk a lot about, and Boeing just signed an agreement with GE Aviation. We were hoping to have some of the panelists from GE. With electric power, if you look at the losses in converting something from mechanical energy to electrical energy, the best turbines used by the electrical companies are 40% efficient. 40. That's the best. That's not good. So if you're trying to do onboard generation with generators or micro turbines or something else, you're already giving up that efficiency. Now you could have micro turbines, because one good thing about turbines can run on almost any kind of fuel. They can run off diesel, jet fuel, natural gas, renewable natural gas. Now we're talking, because at least now you're talking about recycling and things that may not emit dangerous gases. I do believe there's probably going to be an interim or a level where you're going to start seeing change where, at least for short haul and smaller markets, you may be able to see some electric propulsion more in a hybrid kind of capability, because if we can try to harness some of those more, again, re-consuming some of these, right, biological carbon-based things that could run a generator, I think there's an alternative there where at least you're not adding to the carbon in the atmosphere. So I think there is some play there, and I do believe there's going to be some baby steps along the way.
So that whole notion of converting from one energy source into another and understanding the loss is an important one, because some people have even thought about hydrogen being a source for electrical generation. See, hydrogen is really cool. Right now, what you're talking about with SAF is you're not really reducing the carbon that's out there, you're just recycling it. And what you also are doing, if you can go 100% in our industry, is you're avoiding having to pull more carbon out of the ground and adding it to the atmosphere. But hydrogen is the basic building blocks of the entire universe that everything exists in. It is the atomic weight of one. I mean, it is the basics of everything. And when you combine it with things on the planet Earth, it creates different types of outcomes. Well, one of them is oxygen. So you take oxygen, you combine it with hydrogen, and now you've got a fuel source. And what comes out of that, because it's not zero emissions, it's zero bad emissions. What comes out of it is a mist, water, H2O. And so when you have hydrogen, not only are you generating power, but what comes out of the tailpipe, we'll call it, it's not really a tailpipe, but if you think about it that way, what comes out is just water. And that the sky is full of water, the earth is full of water, it just comes down in a natural way, and there is zero carbon associated with that process. So that's why hydrogen is so promising. Until we get to things like blended wing body, which Boeing looked at years ago. Now I'm going to put I haven't been at Boeing, I went to Mitsubishi in Japan, helped them with their aircraft development, and now I'm with 55 Group, but I still sometimes put my Boeing hat on. But Airbus just came out with a design showing that they're looking at a blended wing body aircraft, which means no tube. It's basically the B-2 bomber, if you think about that, it's a flying wing. But that's where you could use hydrogen in that form. I just wouldn't want to be on, let's say it's a flying wing like a diamond or a triangle. I just wouldn't want to be one of the seats way out here on the end when we do a turn. You're going to go way up in the air and you're going to come way down. So there's a reason why they put everybody in the middle of the aircraft for the least amount of change.
Well, you know, you could take a survey and get the most adventurous passengers, the ones that like to parachute and jump out of airplanes, and put them on
They may pay more.
Yeah.
I think that might be a solution right there.
I wouldn't mind being again.
So Ashley, talk a little bit about, so we're talking about life cycle solutions. Sounds like the rust is becoming part of what's adding more disruption to operational efficiencies. And as we know, operational efficiencies is one of the components or the pillars associated with a sustainable aviation system. Can you talk a little bit about what you're doing to address that area?
Yeah, absolutely. So we're partnered with OEMs that are manufacturing not only just in aviation, but also in automotive and other different industry verticals. And when it goes through the production line, we know metal is susceptible to getting corrosion and contamination. So we use our laser technology to remove it before they go into coatings and primer and paint. And that mitigates those returns that they were getting before they partnered with us. So then fast forward to the MRO side of the house, you know, just talking about one MRO specifically that we're working with. They do repair and overhaul on landing gear. And the process that they do, they take it, they dunk it in this toxic chemical to do paint stripping. And there's a time duration attached with that. And then fast forward to after they take it out of dunking, they didn't transition to sandblasting. So now they're using their sandblasting, And that could take whatever that period is. And the environmental engineer is calling me up saying, look, Ashley, I have this very toxic chemical that's impacting the environment. And then we also have, the safety concern when it relates to the employee utilizing the sandblasting and the long-term effects that it has with their lungs. So they're going to be utilizing the laser. So the laser comes in one day, they're able to clean it, and that whole 2-week lead time to just get to the R&O process, we're able to get it done in one day. That's helping out with the efficiencies, helps out with the environment, and all we need is these really cool laser safety glasses. They look like, Oakleys or whatever, and that's it. So.
Well, Sven brought some props. You should have brought your really cool laser glasses.
I should have, yeah.
No, that's fantastic, Ashley. That's fantastic. Sven.
Oh yeah, that's really fantastic. I like it a lot. And especially if we come to problems with paints on aircraft, like the other OEM from Germany, not you guys, the other ones, or for Europe. Then I got something special here. Where is it?
Well, before you jump to that, why don't you talk a little bit about what we started together, what you were doing, and he invited me to join him on the journey. I want to give him 100% credit. North American Aerospace Industries has already been working diligently for how many years? 5 years on how to deal with some of these really challenging. So 55 Group has operations and some presence in Roswell, New Mexico. I was there a few months ago. This is kind of setting up Sven and the amazing things that his company is doing. I was there a few months ago after I toured the Alien Museum and took pictures with the aliens outside of McDonald's. What was really cool there was, and sad, was they were tearing down old aircraft. So at the time, they had about 525 parked aircraft. Rows and rows and rows and rows of United Airlines, American Airlines. I saw one of the beautiful 777s from Air New Zealand sitting out there in the desert. They're all just rusting, and if not stored properly. So there's a cost to storing them, there's a cost to prepping them, they have to be moved in order for them to stay in a particular state. It's a real challenge to manage that. And then some companies ultimately, when the book value of those assets get to a place where it just makes sense to remove them from the books of the company, they pay somebody to tear them down. And what they do is they grab parts that they think are valuable that somebody could buy in the secondary market. They send them off to the OEMs of those parts. The OEMs do a recertification check and on those parts, and then they give them back, and you can make a lot of money just selling parts that are no longer made. However, about 25, depending on the type of aircraft, the age of the aircraft, and the size of the aircraft, 30% can end up just going into a landfill. And the mayor, we were having dinner with the mayor of Roswell, and he was saying how frustrated they are with that process, because even out in an area as big as Roswell, New Mexico, they're running out of space in the ground to be putting all of this wasted aircraft, and it's not doing anybody any good. So that's why we were really excited when we met Sven, and Paul is the one who introduced us, so that's how the connection happened here. So why don't you talk about the journey you've been on with NAI?
So first of all, I would like to say that landfilling any kind of waste is not a solution. I think we all agree on that. I mean, that's a typical thing. If you don't know what to do with it, drive it to a landfill and dump it, and put some soil in it, and it's the problem of the next generation. And maybe they're gonna find it, maybe not. And so, I mean, that's we all agree on that. That's not the solution. So when we started this journey, we were looking really hard into different materials and how we can recycle them. And we especially focused on the last 30%. Because All the other stuff, there are companies around, tear down companies, they tear the aircraft down, they take the value parts out, mostly before they even tear them down. They take out the engines, avionics, you name it, and just park it there for a couple of years, and it's getting rusty. And
all roads lead back to rusty.
But you know, ultimately, when it relates to the rust problem, that's where we're trying to penetrate the market now, so we can extend the life of the aircraft.
Yeah,
that's what we're trying to target. So,
especially with the composites.
All of us were so impressed. We had the pre-meeting,
Yeah.
and he just, while we were waiting for the host to come on the meeting, he starts advertising with his videos, and we're just like, oh my God, that's amazing. Go ahead.
No, that's really cool, because that's going to solve a lot of solution, even for the guys that are selling the scrap, because it's contaminated with the paint. So in some parts you have to remove the paint, and then you're in the same situation than before. You need the toxical stuff to remove it, and then you have environmental problems. And with the laser system, that's pretty cool. So that's why I was jumping on it. It's like, it's really, really cool.
One too, right? You're one.
Oh, of course, yeah. Shut up and take my money.
My R&D guy.
So yeah, we're specialized in the last part of the tear down or the recycling. So that's why I brought some interesting products with me, which we recently did for a major carrier from the Middle East. We do funny stuff like this particular backpack here, where you can see we've got the buckles and belts integrated in it. This is made from business class and economy class seats. On the backside you can see the belts, of course. We got some other interesting stuff you can make from it, like we do have shoes from the same materials, so you can wear them actually as a set, shoes and backpack. There's many more things you can do with it. Maybe that's the more familiar one for here. That's the European shoe. That's the one from the United States. But we used a German airline for the leathers that we used here. Everyone knows the colors, so I don't have to mention the name. Yeah, I mean, there's even plastics on board we can recycle, and then we do really fantastic stuff from it, like let me just pull it out, like sunglasses. So there are so many things you can upcycle the materials on board if you just think about it. And thinking about it and finding a way, that's what I'm here for, all of us. Thank you. Steve?
And I know this guy, I'm friends with him. So we've had people come by our booth. Lena, what booth number? 361. Yeah, we've got to throw that out there. And they saw our sign on recycling, and they were kind of like, oh. And then they saw these bags and these shoes, and they're like, oh, this is awesome. This is amazing. The other thing that has driven us to think about, back in the day when we were designing aircraft at Boeing, and Airbus has gone through the same process, aircraft were designed #1 for performance, fuel, payload, range, operating costs. All of these things are what drive the design of an aircraft from an OEM perspective. But then they got to the factory, and the factory tried to do things like lean manufacturing, and they tried to streamline the manufacturing and assembly process. And what came out of that was, we have to change the way we design these parts in order to go together easier in the manufacturing, so we can have more streamlined manufacturing. So that led to an initiative called Design for Manufacturing, which means you had to balance performance against assembly time when you were designing your parts, and all the engineers had to design everything on the aircraft this way. The third thing that came along now that we think is going to be the next phase is design for sustainability. So not only are we looking at the manufacturing processes, which Ashley is not Rusty, his name's Ashley. What Ashley clearly said is there's a lot of chemicals that are very hazardous involved with development and manufacturing of aircraft. We got to find better ways to do that. But at the end of the life, do you know how much time when you guys have to throw your trash out and you're separating the organics, from the plastics, from the cardboard. It takes time to do that. If we could just do things in a way that makes it easier, it's going to move so much faster. Well, Sven and his team have to spend so much time because all the plastic is recycled, because none of it's going to go in the ground. One PSU, okay, first of all, who in this room knows what the 3-letter acronym PSU stands for? What's that? It could be a power supply unit, but in this case, that's why we had an acronym dictionary, because it gave you 40 definitions. They call it a personal service unit. So a PSU is a personal service unit. This is your lights, your Gasper valve, otherwise known as the air valve. That one piece alone, when we take it out of a dead aircraft that we're recycling, has 5 different plastics. So you can't throw them all together. It has to be broken down, and this plastic has to go in this bucket. This plastic has to go in this bucket. It's time consuming. So if the OEMs understand what the goal is, we can start recycling and designing from the beginning for sustainability. Why don't you show them your clock too? The clock.
Oh, the clock, oh yeah. I was just trying to refer to that. I mean, we have to see what the OEMs are about. They are about to sell their aircraft. So they don't care what's happening at the end of the life. And that's what they have to change. They have to change their thinking. And I think it's a big problem, because they are big companies. And so they're not easy to move. They're not flexible. We all know that. They are full of bureaucracy. And they have so many different levels and stages and management levels that have to approve something before you can even get a application for something. You know, it's so crazy. So this is going to take some time. The question is, how can we put pressure on them? How can we, as the aviation supporting industry, put pressure on them to move into the direction we want them to move? Or not we, because I mean, I'm 52, I'm maybe here for the next 20 years, 25, whatever, but I have children. So we do it, in fact, we do it for them, right? Because we just borrowed this planet from them, and we should give it back in a better situation than we got it. And that's actually my goal. That's why I'm doing that. What was the question?
I have 6 grandchildren. That's why I'm doing it. Yes.
Oh.
So
that's productive.
I had two rabbits for kids. So they're just out there multiplying. So Sven, you're 100% right. So think about it. What could we do? What could you do? Think about it. Sitting there in your seat, what could you do? But there is a paradox. There's a dilemma. There is a creative tension here. I used to go on sales campaigns selling aircraft around the world. In 2019, I started with 0 miles on Delta Airlines in March, and by October I had 500,000 miles. Think about that. How much traveling, how much aircraft time that was. Now, when I was at Boeing, if we were having, hypothetically, a campaign in Australia, we would bring 20 people all the way to Australia to have a 2 or 3 day conversation, because everybody had to present their little piece of the story, and then they'd all come back, and then we would do more work, and we'd fly back with another 5 or 10, and we'd fly back. Sometimes there would be 20 trips to sell one aircraft. Now think about that. In today's world, should we be traveling that much every time you want to talk to your customer? Then the other side, where the paradox comes in and the dilemma, is we're encouraging people to fly because we're in the aviation business. And every single person, including the people in the back who are running this place, because we're paying them as a result of this conference, every part of this event only exists because you buy a ticket, because somebody bought a ticket. Because at the top of the food chain, the airlines aren't making money, they're not buying airplanes. If they're not operating aircraft, they don't need your services. They don't need your parts. They don't need your maintenance. They don't need our recycling. So everything starts with people buying a ticket. So how do we do this where we're not telling people not to fly? Because we believe wars are going to be stopped. If we connect the world and people see each other face to face, you realize there are human beings over there with families and grandmas and grandpas, and everybody is just on this earth trying to survive and make a living. So how do we do this? So that's the challenge, to kind of go back to the topic here. The challenge of sustainability in aviation is find solutions that don't drive, that the answer is not don't fly. The answer is fly responsibly.
So,
any last comments from the team?
Yeah, absolutely. So if there's a way we could get the slides up for Laser Photonics.
Can we show the laser?
Just number 2.
Video? Is it a video?
Yeah, actually,
It's the
what makes
second.
laser so safe, and what makes it so great?
Well, yeah. So I was just trying to get the slides up here, but ultimately, what our mission is to work with the OEMs. I think it's up there.
It's up there, yeah.
You could put on. Okay, it's good. Second slide. Okay. We're working with the OEMs right now to try to extend the life of all their piece parts, their components, whatever that relates to metals, because ultimately extending the life of those piece parts and those components and the aircraft parts is what our goal is, because we're all talking about sustainment here. Because as you mentioned, there's a lot of aircraft that are going to these graveyards, and they're just going to sit there, and then they're going to eventually put them under the ground. And we want to keep that extension of life and all the piece parts, components, and our laser technology can do that. We can help extend the takt times, because we all know everything has to be done yesterday in our industry. The expectation is very, boom, 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 boom. So instead of a 2-week lead time on an R&O for landing gear, now we're pulling that in one day, don't have to do any toxic chemical waste, EPA's upset, expensive regulation. Then we don't have to go into sandblasting either, impacting the long-term health of the lungs, impacting mitigation of someone slipping inside that cell. That's just one example of many. And getting in front of the OEMs and getting them to see the long-term effects is kind of what my goal is when I'm partnering with these OEMs and MROs. And another little obstacle is, the FAA and the certification aspect of it. But please come see us. We're in booth 529. So that's me. That's my last minute.
Booth 361.
529 and Rusty.
Last words from Sven and Paul?
Yeah, just one more thing. Just one more thing. I want to come to Ashley again. One of the Middle East carriers that we work with had some issues with the European OEM and their paint. Maybe you followed that. And that's where I thought would be a good idea for you guys to come across. And that's actually why I brought a piece of one of these aircraft with me that we converted into a wall clock. So this is a window cutout. It's just for my office, but of course we can customize it, and we have lots of them in the production. So
Airbus?
Yes.
That's Airbus. Yeah, that's A350. That's why I was referring to.
787 window,
Oh, we have 737s as well.
Well, they didn't have the same paint issues that
Yeah, and the thing is with the recycling, and that's something I would like to address to all of us. Recycling comes with an F word. So you have to do something.
Yeah.
And please, guys, do it. I know it's cool to go to Starbucks and take the paper cup and run around with a paper cup and throw it away. But if you know you go to Starbucks, why don't you bring your own food container? Why don't you bring your own cup? It even saves you money. They're gonna give you a discount. That's just one example. And I mean, you guys got plastic there. Look at me, I got a can. So,
I didn't break the rule today.
He set us up. He said, you made those things.
Yes, he did.
exactly.
So, Paul?
Yeah, so I've talked a lot about fuel efficiency and the fuels, and the reason I did that was, and afterwards we actually invited the CTO from Boeing that's responsible for sustainability to attend. Unfortunately, he had another engagement already, but from a Boeing perspective right now, as I go back and talk to some of my my peers, is obviously, Boeing's in the market primarily for selling new aircraft, but the folks in this room really deal with the ones who deal with the rest of the life, right? And that's really where a lot of it is, and it's going to have to come from this side of the industry, I think. And it's funny because when I first met Sven and started looking at this, I approached Boeing thinking, yeah, they're going to really want to do this, and they're like, we like it, and we would absolutely support you, but we really can't devote our resources to that aspect because they really need to make sure flying stays affordable and available to the masses, right? And so it really is going to be up to folks, I think, on the MRO side and the end-of-life side and support side to figure out how do we do things differently. Now, is there a feedback loop here to Boeing? Like, hey, we've learned all these things about plastics because everybody already knows aluminum. Everybody always thinks aluminum, yeah, we can recycle aluminum. That's the easy part. It's all that other stuff, especially the interiors, right? So if we can get that feedback back to the Boeing engineers, you know, I was one, and there's no reason we couldn't do it, right? There's no reason we can't design it in to say, okay, we could spec it out to our suppliers and say, make it only out of this one kind of plastic, and that's what we want, right? So that can be done, but I also believe there's going to be at some point there's going to be a legislative component, I believe, where at some point towns like Roswell or Tucson or Victorville are going to say enough.
Yeah.
We can't keep parking airplanes here.
There you go.
And so you don't want it to be a reaction and a penalty. So we've been trying to drive incentive into it. And so how do we incentivize airlines? How do we, the leasing companies, right? Because a lot of the airlines have active airplanes, but how about the cargo companies, the leasing companies?
So along those lines,
yeah.
Thank you. I've almost forgot about that. I'm also the chairman of a company in Dublin, Ireland called Global AVX. And that company is in the heart of lessor land. As a matter of fact, it's a 1,500-year-old building. 1500s is when it was built. I'd have to do the math how old it is. But you could stand on the roof of that building and throw a rock, and you'd probably hit the companies that own about 40% of the aircraft in the world. There's a movement happening among the lessors. The shareholders are putting pressure on those companies. There's an entire movement and a new initiative called Impact in Europe that is all the people who finance aircraft in large, we're talking billions and billions and billions in orders. They're all the banks and the capital markets and the financing markets are getting together to say we're only going to be loaning money for new aircraft for those that meet certain standards around sustainability. So if it doesn't come from the ground up to the OEMs and the rest of us in this industry, it's coming from the financing side because they have standards out there that are not just reasonable, it's responsible. So with that, I'd just like to say thank you for your time. I hope you enjoyed our little banter up here. Thank Rusty and, no, I'm just kidding, Ashley, Paul, and Sven. Thank you guys for coming up here with me, and have a wonderful rest of your conference here. Are we auctioning? Oh, oops.